What makes the processes we develop different is that they are using different source of energy. Today, most of the metallurgical processes use combustion, which could be hydrocarbonated compound or directly coal or natural gas or other sources of combustion. And unfortunately, using gases and this type of fossil fuel in order to power up metals extraction technologies and do the chemical work that we expect from those processes. Unfortunately, these two things are very difficult to do at a smaller scale. They are very difficult to handle if they are not done at a very large scale, first of all. And second of all, they are very difficult to ramp up and ramp down. What we are proposing that is different is to use electrons primarily as our way to reach the high temperature, which we know can be reached very, very quickly with electrons, but also to use electrons to do the chemical work. And this, we know that electrons are the most selective, commonly available form of energy that we can carry around. So the combination of substituting hydrocarbons with electrons for the high temperature part and the heat part, as well as electrons to do the work, the electron work, help us to provide technologies that are more scalable, on one side up as well as down. So I'm talking here about production rate. And at the same time, it means you can start them up and ramp them down more often with less consequences for the safety and for the operability of the process. Our experience in alternative potash for Brazil showed us that logistics is extremely important in our modern society. When I say logistic, I could almost say network, in the sense that Brazilian farmers, many of them are thousands of kilometers away from the port. And that means that the goods, assuming they want to export the crops, have to be able to travel all the way back to the port. But on the other side, because they don't have access to local fertilizer that would be made in, next to the farm where they are, they have also to rely on importation in order to get the yield that they need and to amend the soil in a satisfactory manner. That reliance of importation means that because of the relatively cheap cost of fertilizer, it means that it's going to come by boat all the way to a port. But then, in order to distribute the fertilizer on the scale of a country like Brazil, the amount of infrastructure necessary to make that cost effective is probably never going to be there. It's actually, you may even wonder if it would be suited to develop all that logistic and infrastructure, knowing that it's going to cross through cities, it's going to cross through rivers, it's going to cross through forests. So ultimately, I'm not even sure one day someone will develop sufficient infrastructure and logistics to match the intensive trade that is going on with agriculture. And that what this is telling us is that the sustainable version of that is to have local fertilizing resources, local energy resources, to allow the farmers wherever they are to be more cost effective at having high yield and better agricultural products. If you start to think this way, you're even wondering if you really want to make corn or soya to be exported, or soybean to be exported all around the world. Maybe actually, if you have better fertilizer and different soil, you could think of growing different type of crops. The challenge of organic farming is all around having local and cost-effective and biologically effective fertilizers that don't rely on the intensive chemical processing of conventional fertilizer. So the experience with Brazil tells us that if you want to support entire regions of a country in their endeavor, for example, in farming, you need to find an integrated local solution that is independent, that is shielded from all the fluctuations that are going on in the global market of these commodities.